Now, what happens is with the sudden stratospheric warming, which often happens in the springtime, is that you get higher pressure and warmer air moving up into that core region. This happens very quickly. It can be a very quick, abrupt event, and we call it a sudden stratospheric warming. Early to mid March, just over a month ago, month and a half, we had this occur in the polar vortex high over the Arctic, and it basically collapsed the polar vortex.
Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons. I'm the author of A Climate Vocabulary of the Future, and we're happy that you're here with us today. And today's topic is a very simple one, but it's also one that has potentially far-reaching consequences. And we're going to be talking about polar vortex collapse, what that means, what the implications are, and a little bit about the science behind that and the impact on you and your daily life, depending upon where you live. Basically, we have a strong stratospheric warming event that occurred a few weeks ago. So this is very recent. That's part of the reason we're doing this program, because we want to keep you up to date on some of the, sort of late breaking impacts that affect us and that scientists and others need to include in their calculations and their studies or so. So that's what our focus is today. We are, as always, happy to have with us Paul Beckwith, who is a climate systems scientist from Ottawa and has one of the most popular YouTube channels on climate change with well over 1,000 videos covering every aspect of the climate crisis. So, Paul, what in the world is polar vortex collapse, and is it really as serious as the title that we give it that's called? And it's not just us giving it that title, it's what the newspapers and others are calling it. Tell us about it, Paul.
So a vortex is something spinning, right? Think of your toilet bowl flushing, right? You got a vortex of
I'll
water.
try not to, but all
So,
right.
so we have a tropospheric polar vortex, but we don't call it that. We call it the jet stream, right? It circles the pole. It's in the troposphere. It used to be much stronger and straighter, less meridional, less north-south, more east-west, more zonal. And up, that's in the troposphere, lower atmosphere. But the stratospheric polar vortex, we dropped stratospheric normally and just call it the polar vortex, and it circles in the stratosphere, and it's really cold in the stratosphere and it's low pressure. And when you have this vortex spinning around this very cold, low pressure area, the colder and the lower the pressure, the stronger the wind speed, the stronger the vortex. Which direction does it spin? Well, in the northern hemisphere, you have the Coriolis force deflecting things to the right. So the high pressure air tries to go to the low pressure right over the poles, deflects to the right, causes the air to move that direction, which creates a counterclockwise vortex. A very healthy, strong polar vortex, very low pressure in the center, very low temperature up in the stratosphere, very high winds. It's centered normally around the pole. Now, what happens is with the sudden stratospheric warming, which often happens in the springtime, is that you get higher pressure and warmer air moving up into that core region. This happens very quickly. It can be a very quick, abrupt event, and we call it a sudden stratospheric warming. About a month ago, early to mid March, just over a month ago, month and a half, we had this occur in the polar vortex high over the Arctic, and it basically collapsed the polar vortex. It broke down, it didn't have its order, it split. This has ramifications for because that occurrence then propagates downwards into the troposphere where it can affect the jet streams. So I don't know, does that help a little bit?
That helps more than a little bit. Do we know, or does the scientific community have a indication of what are the major causes or cause of the vortex? How much is global heating responsible for it? Is this a controversial or an area that there's division, or most scientists sort of agree to what the causes are?
Well, I think it's an area definitely of very active research. I mean, we do know quite a bit about it, but we do tend to talk a lot more about the jet streams because they have a direct effect on us. And, as the Arctic is warming really rapidly and there's all of these positive accelerating feedbacks because the Arctic's getting much darker with the loss of sea ice. And then that's, of course, causing more solar absorption and greater warming of the Arctic. We have this Arctic temperature amplification where the Arctic is now, most people say it's about 3 to 4 times faster warming than the rest of the planet. Depends really on the latitude. The closer you get to the pole, the larger the warming is compared to the global average. So, we talk about how this slows down the jet streams and causes them to become wavier in the north-south direction, get all these weather extremes as a result, because the very wavy jet stream means that you have ridges of the jet stream going up into the high Arctic. Warm air goes up underneath the ridges, can melt even the North Pole, cause temperatures above zero temporarily at the North Pole. And then you have the troughs, which go deep south, carrying cold Arctic air. So you get a lot of this going on. We now talk more about the polar vortex, the stratospheric polar vortex collapsing because it weakens as we go into spring and summer, right? It's more of a winter event for each hemisphere. But what we're seeing now is very abrupt, very sudden, very rapid changes happening a lot more often than we did before. So climate change is having a huge impact on global circulation patterns, which are basically occurring because of, leading to the jet stream and phenomena like that. We talk about sort of local patterns and global patterns. The net result is, for example, because of this polar vortex collapse being very sudden a month and a half ago, it's actually causing huge impacts to the weather patterns that we're seeing right now across North America. So a perfect example of this is Ottawa. Okay, I'm in Ottawa. Yesterday afternoon, it was 25 degrees Celsius, or for you guys down south, multiply by 9/5 and add 32, that gives me 77 Fahrenheit. It was in Ottawa yesterday, unusually warm for this time of year. And then it dropped to 0 Celsius overnight. So it dropped 25 Celsius. It dropped to that's 32 Fahrenheit. I'm sure you know I don't need to do the conversion for our American friends using Fahrenheit. But anyway, that's a huge swing. And then today, it's not quite 25. It's more like 15, closer, approaching 20. But as a result, during those transitions, we had very high winds, right? Because you get a huge temperature difference. You normally have a cold front coming through, and that cold front generated very high winds, very stormy conditions, and it knocked the power out to, I don't know, 120,000 people in Ontario yesterday. We joined Spain and Portugal with their power outages for different reasons. It's still unclear what caused those outages there, but we're seeing more and more, I call it weather whiplashing, right? Where we go from, you can have weather whiplashing on very short time scales, like on day to day time scales. One day it's super warm, next day it's super cold. You can have very, very warm temperatures at high latitudes and then snow and very cold temperatures at much lower latitudes, right? And then as the jet streams move past, you get a whiplashing from one to the other. Also call it weather weirding, call it weather wilding. Even Newton's interested in what I'm saying. So you get very unsettled weather, and we're seeing more and more of that happening, and it can have huge effects. Like there was a weather whiplashing event, like in BC, I think a few years ago, and they had the apple crop, all the buds came out, it was really warm. So you can have whiplashing on longer time scales. So it could be very warm for a week, and then a week after that, go very, very cold, below zero, kills all the buds, causes like $100 million of damage to the apple crop, for example. So we're seeing more and more disruptive weather patterns like that. So the polar vortex is another part of the equation leading to what's causing to the changes in the jet stream, which we've been talking about for many, many years.
I'm wondering whether when we think about, or I think about the polar vortex, of course, I need to think about the fact that there are two poles and not just one. Is there a polar vortex in the southern hemisphere? And if so, does it operate similarly? And of course, there aren't people there within, 20 or 30 degrees latitude. I guess maybe the tip of South America would be pretty much it. And is there any connection between, if there is this vortex, the two vortices, if that's the right word?
Hmm. Yes, excellent question. I mean, as you said, we're certainly northern hemisphere centric in what we talk about. The vast majority of land areas at high latitude are in the northern hemisphere. You can look at the population distributions, and there's very few people in the southern hemisphere relative to the northern. So we tend to focus on the polar vortex around the Arctic, around that pole, but there's also the equivalent thing in the southern hemisphere, but I think the Antarctic is always extremely cold. Although it has warmed, it's warming, with Antarctic temperature amplification compared to the global average, it's still well below zero and very cold. So the polar vortex changes in the southern hemisphere are much less abrupt as what we're seeing in the northern hemisphere at the moment. There's strange things going on in the southern hemisphere. I mean, from 2015 on, we've had a collapse of the Antarctic sea ice, for example. We've had more intrusions of water, warm water coming underneath the ice sheets that are resting on land that's well below sea level. And so we're getting disruptions globally of different sorts. The Antarctic thing, I think, has surprised a lot of people. So the polar vortex is definitely changing. And sometimes it's not just a matter of weakening the polar vortex, say around the northern hemisphere one. Sometimes it actually gets offset from the pole. So it's no longer spinning centered on the North Pole, it's offset. And if it gets offset quite a significant amount, then the lower latitude parts of it can have huge impacts on the jet streams underneath and many people that are living on the continents underneath. So the disruptions to the polar vortex. I mean the theoretical perfect polar vortex is a very fast circular vortex of air centered on the North Pole, and then you can get it offsetting, and then that can lead to it breaking up, or you can get a huge rise of pressure and temperature, which can split it into two. So instead of one polar vortex, you have two circulating vortices, which again can then impact the lower altitudes and affect the troposphere and the jet streams, and things can get very fractured and chaotic in the weather patterns, and we're seeing that also. It's all
Hmm.
part of the extreme weather events that have been rising. And also, like you can look at Ottawa, for example, again. In the winter, it used to just get cold and it would stay cold. It would be cold for all winter, right? Now you get swings of temperature like above zero for short periods of time, and then it goes back to well below zero. Then you get another swing way above zero back to below zero. This is in the winter, and I think this sort of pattern has occurred. I believe I read somewhere it's happened 37 times this year, this winter in Ottawa. I know the people that work at the city are well aware of this because it wreaks havoc on the roads, right? Think like water goes into cracks and it freezes and it thaws and it freezes, thaws. The roads are a complete mess. You need a tank to drive along them at some points in the spring, right? So the budgets are way higher now than they used to be. So it does have real impacts on people. Like on farmers, do they plant? It gets warm, buds start coming out. Do they go gung ho? Or are we going to get another killing frost or freeze, say, the following week or the week after that? So it really makes things challenging for a lot of different people.
Well, there was one question that I asked about to what degree is this related to or caused by quote unquote climate change? But then there's the related question of to what degree can climate scientists and sophisticated weather forecasters anticipate, a kind of a breakup, if you will, or a collapse
Right.
or other aberrant behavior, if that's the right word, to prepare people to be able to say to people, whether they're farmers or school kids, or all of us really who are affected by the weather. Is this only possible to sort of predict retrospectively after it happens and say, ah, now we see why it happened? Or
Mhm.
do we have the tools and the models and the intelligence to be able to anticipate what may be coming about with respect to the polar vortex?
I think like when it does happen, we kind of know about a week beforehand that it's starting to initiate. Like there's some signs that are given, and as far as but we don't know like say a month or 2 months ahead of time. We don't know the season ahead of time when it's going to break up. But there's some things we do know, like we know that the greenhouse gases in the lower atmosphere cause huge warming, right? They trap heat on the surface, they cause warming, and the troposphere tends to heat up more, and the greenhouse gases trap the solar radiation that's radiated out, the long wave radiation that's radiated out from the heating of the Earth, right? That all heats up the troposphere, but it means there's less energy going into the stratosphere. So climate change causes a stratospheric cooling, right? It causes it's global warming that's in the lower atmosphere where we live, but it actually cools the stratosphere, and it can cool it quite significantly. And a cooling of the stratosphere, along with low pressure, can actually increase the strength of the polar vortex,
Mm.
right? So it can actually be much stronger because of climate change. But then, when the spring comes and things start to warm up a bit, and you can get these events like these sudden stratospheric warmings, which are much harder to predict, but when they occur, they happen very fast and they can split up a more powerful polar vortex. The extreme weather events that result from the disruption of the jet streams, which is directly tied to the disruption of the polar vortex, can be that much more severe, with our warmer climate, if that makes sense.
A lot of people may wonder about the potential change in the behavior of the polar vortex, or for that matter, almost any other weather or climate phenomena. Let's say hypothetically that we as humanity are able over the next 5 years to reduce our emissions by a substantially greater amount than we have been able to do so, which isn't saying much since we haven't reduced the emissions at all, essentially. They've been flat or slightly up or slightly down, except for the first year of the pandemic when they dipped and then came back up again. But I mean, let's say we were able in the next 5 years to reduce emissions by 15%, 3% a year, give or take. Would we notice, or do scientists are scientists able to tell us that 5 years from now there would be a noticeable difference, presumably an improvement in the climate and in the extreme weather, whether it's the polar vortex or other climate phenomena?
Yeah, I mean that's a tough question because
That's why I asked it.
no, I know. I think what it gets to really is we're definitely a tropospheric species. We don't think about the upper atmosphere too much. We do now with more satellites up there and space programs and so on, but we don't really think so much about the stratosphere. I mean, we did when the ozone layer was vanishing. I mean, of course, there's a connection to the ozone layer destruction and what else is happening in the stratosphere. There are more other factors that connect the two regions. For example, when there's extremely strong thunderstorms, right, these cumulonimbus clouds, there's huge convective uplift. They extend from basically low above the ground right up to the tropopause, right, the upper parts of the troposphere, and you see that anvil shape in a thunderstorm. That's where the tropopause is. The troposphere is ending, stratosphere is beginning, and you can get a lot of water vapor injected up into the stratosphere from these massive thunderstorms. Of course, when there's any volcanoes going off, they're sending lots of material from the troposphere up into the stratosphere, including the sulfur, which cools the planet. There's also, if there's very strong winds and high mountains, then you get a strong vertical component to the velocity of the air moving upwards. Say, as it's climbing the edge, the side of a mountain, And that some of that air can actually have so much velocity that it's actually carried and can overshoot, and parts of it can interfere and affect the stratosphere as well. So there's all of these different factors that sort of complicate the picture. We're not neutral. I'll just give one example. We have a lot of satellites re-entering, and when they burn up in the mesosphere much higher than the stratosphere, they can put a lot of aluminum particles into that region, and over time, gravity can pull those down and in towards the stratosphere where the ozone layers are, and it can act as a catalyst to destroy ozone. And I think as we do more and more of these sort of uncontrolled experiments, we might find connections to the polar vortex and other things like that as well. So, we don't live up in the stratosphere, so we know a lot less about it than the troposphere, but we're finding out more and more things. And I think Charles will put some links to some of the articles that we've used, in preparation for this video, and like Severe Weather Europe has some fantastic articles about the polar vortex. And there's actually a couple scientists in the US, and I think they collaborate with some European scientists, and they do a sort of regular article or bulletin on the state of the stratosphere and the polar vortex. And they actually, try to predict when it will break down and things like that. So there's some excellent material out there, and I hope it sticks, or it stays there. I think it's done independently by these U.S. scientists, so I hope they're still doing this sort of thing, given the politics in the country.
Maybe I was daydreaming, but I don't think you answered my question.
Well, I said it's a really good question,
I
so
know, and we both agree it was a really good question.
yeah. So I don't think we know
Okay,
the answer to it. I think
fair.
there's a lot of different theories, maybe, but I think maybe we should consider, if we do another show on the polar vortex, I think maybe we should ask some of the scientists that are spending the bulk of their research on this very specific topic, because it's changing quite a bit. I mean, there are more, if you look in the literature, there wasn't much about it, say, 10 years ago, and now there's way more stuff being published on it, but there's stuff that's coming out. One study comes out on the polar vortex does this, and then another study comes along and says, no, these guys are wrong. It does this instead. And so I think it's an area still in great scientific flux.
Yeah, I mean, part of the reason I asked that question is because it's my impression from a little bit of scientific reading, there's some evidence that even systematic and radical, sharp reductions in emissions over the next couple of decades that would get us to or near decarbonization or net zero may not have a noticeable effect on the climate and on temperatures for a considerable period of time. They may prevent temperatures from increasing, but they wouldn't necessarily result in temperatures or impacts decreasing. And I think that's really critical for obvious reasons that we put in all these trillions of dollars and all this effort by the world community. And we may find, and this is really a question more than a statement,
Mhm.
and obviously it's a broader question than our focus on the polar vortex. And maybe we should have a program on that where we really talk about what difference will it make if and when we reduce emissions to, what life is like in 20 years or 30 years or so.
I mean, to some extent, I agree, but there's some things where, I mean, if we wanted to, we could cool the planet a degree in 6 months, right? There's
I
only
understand.
one way I know how to do that, and that's with sulfur. And
I know, I understand that. I'm just talking about emission reduction.
so, yeah, well, I don't think, it's hard to realistically think that we're going to cut emissions at this stage.
Well, but that's another question. I want to
Yeah.
focus on the question. And if
There,
we
there,
are successful, what is the impact?
yeah. The impact is going to occur, but I think it's going to be fairly slow. I think there's a lag in the system.
Yeah. Yeah,
So
that's
that's why I think it's absolutely vital, as you know, and you agree, and many people, mainstream scientists, vehemently disagree, right? With things like sulfur aerosol injection into the stratosphere, things like that. But I think we're really running out of options. And I think it's for us to think that emissions are going to drop significantly, I think is a bit of a fairy tale and fantasy at this stage. I don't see, I mean, we've shown no political will in the globe to do this,
Hmm.
right? So, we can end every show by saying we have to slash emissions and stuff, and like everybody else does, right? But makes those statements. But, is there any like there's no sign that we're even heading to that direction.
No, in fact, the indications are that not just in the United States, but throughout the world, there is a pullback or a drawback by major industries, by the banking, many countries in their climate ambitions. Let me ask you a last question, which is, what should the audience take away from what we've talked about the polar vortex?
If you want to understand climate change and what's happening, there's a couple key things that you have to kind of, read up on and figure out, try to educate yourself on. And, the biggest single thing I would say is the jet streams. The other big circulation of heat and energy on the planet, of course, is the oceans and the ocean currents. They're moving a lot slower than the air movement. And then the polar vortex has a key role in the behavior of the jet streams and what happens there. So that's a very important connection too. So how heat and energy move around on the planet is key to having a sort of better understanding of extreme weather events and maybe how things will affect where you live and so on. And the other thing is you have to protect your own mental health, right? With all of these negative things happening. So I'll be doing a video very soon on there's a new report that came out, the Happiness Index 2025 just came out, a 250-page report on happiness globally around the world. And unfortunately, it's gone down quite a bit in the US.
Um, yes, I think that's the case in my neighborhood and maybe even in my own household here.
So I
Uh,
think puppy sales might skyrocket.
well, I want to thank you as always, Paul. I mean, you started out the program by giving a metaphor about toilets, and you ended up with the happiness index. And to me, that reflects the kind of scope of your mind and the scope.
Yeah,
Excuse me.
I don't know if that's a good thing, but it is what it is, right?
And the scope of the climate emergency forum. So, if you liked this program today, please like our channel and please subscribe so that you can get our weekly notices of our sessions covering virtually every aspect of the climate emergency. Please go to our website, climateemergencyforum.org. Take a look at the many articles that we have there that supplement what we talk about here. And if you're so inclined, and we hope you will be, we could use your donations so that we can continue to basically be one of the best, we believe, one of the best and most comprehensive sources on the climate emergency that you'll find anywhere. So, with that, certainly tell your friends and neighbors about our program, and we look forward, as always, to seeing you next week. Thank you so much.